Hello, my name is Shock, and this is the first video for the Fundamentals Academy YouTube channel, part of the Physics Fundamentals Bullet Course. Today's video will be all about motion, because even your sneakers obey the laws of physics. So, motion is the change in position of an object over time. Everything around us is in motion, from the smallest particles to the largest planets. Whether it's the earth spinning or a car driving down the road, motion is happening everywhere. Now, there are four types of motion, and each one describes how an object moves in space. So, linear motion is motion along a straight line. And an example of this is a car driving down a road. Circular motion is motion around a fixed point. An example of this is a fan blade spinning around its center. Oscillatory motion is motion that goes back and forth, like a pendulum swinging in a clock. And finally, rotational motion is motion where an object spins around an axis, like how the Earth rotates around its axis. Now, to understand motion, we need to define a few key terms. The position is location of an object in space. Velocity is how quickly its position changes. And acceleration is the rate of change in velocity. Now, these three values are vector values. A vector meaning it has both magnitude and direction. Now, distance is the total length of a path. Time is the duration of the movement. And speed is how fast an object is traveling. Now, these three values are scalar values because they are a quantity that has magnitude but no direction. Now, the frame of reference. It's important to understand the frame of reference because motion is always described relative to something else. For example, a person sitting in a moving train might appear still to a passenger, but to someone else standing outside the train, that same person is clearly in motion. This shows how different observers can perceive the same motion differently depending on their frame of reference. Now, part one. I'll be covering speed and distance, acceleration and velocity, and displacement in this video. So, speed and distance. As we covered earlier, speed is a scalar value and distance is a vector value. Speed tells you how fast something is moving, regardless of direction. And its units are in meters per second or kilometers per hour. Distance is the total path an object travels, measured in meters or kilometers. For example, if a car goes 100 meters north and 300 meters east, the total distance is simply the sum of both paths, which is 400 meters. Now, some people like to remember this formula when calculating speed, distance, and time. So this is called, I guess, the speed, distance, time triangle. And when you cover the letter, like if you want to find out the speed of something, you cover speed, and the remaining two letters would be distance and time, and distance is over time, so you divide distance by time. Now, acceleration is the rate velocity changes over time. It could be an increase, a decrease, or even a change in direction. For example, a Pagani accelerates from 0 to 100 kilometers per hour in 2.8 seconds. Now, step one to calculating its acceleration would be converting kilometers per hour to meters per second. This would be 100 kilometers per hour. So 100 times 1000 divided by 3600 is equal to 27.78 meters per second. Step 2 is to use the acceleration formula, which is the final speed minus its initial speed over time. And step 3 is to substitute the values. So 27.78 minus the initial speed of 0 divided by its time of 2.8 seconds gives us 9.92 meters per second squared. This means the Pagani accelerates at 9.92 meters per second squared. Velocity is the rate of change of displacement, and it includes direction, so it's a vector value. So if a drone flies 100 meters north in 20 seconds, its velocity is its displacement over time, which would be 5 meters per second north. Displacement is the shortest straight line distance from the starting point to the end point, and it includes direction. Even if you take a longer path, like turning corners or looping around, your displacement only measures the direct route from start to finish. For example, in the second image, you walk 600 meters east, then 240 meters north, which is a total of 840 meters. Using the right-angled triangle, we can solve for the displacement using the Pythagorean theorem. So here's the second image. The displacement would be the square root of 600 to the power of 2 plus 240 to the power of 2, which would be the square root of 360,000 plus 57,600, which can be simplified to 646 meters. So the displacement is 646 meters in a direct line from start to finish. Thank you very much for watching this video. If this video helped, please give it a like and hit subscribe to stay updated with the next part of the Physics Fundamentals bullet course. The next video will be Force Fundamentals, covering friction, force, and Newton's 3 laws. Thank you.